Hello, 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 hello. Just sorry, please. Hello, guys. Today we will discuss some DSA questions. So let's start. Wait a minute. I'll be back in 2 minutes. So I should come clean here. All right. So hello, guys. In this video, uh, we will discuss some DSA problems for interviews. आना जाना में कम. हम्म? टेस्ट ना क्लास चलेगी लाइव. So let's start this session now for 45 minutes here. All right. So first question we will encounter is from lead code it is. So question number, find duplicate in array. All right. Find a duplicate in array. This is which problem in lead code? I don't know. So let's start lead code and try to solve this. Where is my lead code? Am I sharing my screen or not? Wait a minute. Let's share my screen. This and window. But can we only one here? All right. So I have to do this. All right. So what we do here, guys, is um, lead code is starting. Our first problem here is, guys, uh, find duplicate in array. Filters. This is the question. So what is the question here, guys? Is given it and return true if any value appears at least twice in the array. Return false if every element is distinct. All right. So this is the question. So in this, let's say this is a input array nums here, and it is returning true because one is all right. there is a duplicate in this distinct, so is it returning false? So how can we approach this question? There are let's take this example only, 1 2 3 and 1. This was the array there. So nums 2 3 and 1. So this is the example. How can we solve this? So how can we uh, so one approach would be brute force approach, all right, which is like one for index. This is zero index. This is one. This is two and three. For index zero, we zero for the element of zero index, we traverse entire array to check if this element present in array or not. So we have to visit in order of n minus 1 in worst case, and same for 2 in worst case order of n minus 2, like this, 3 order of n minus 3. So in the worst case we can go like n minus 1 by 2. This is order of n square time complexity, which is very not very good. So what can we do uh, to for optimal approach? One is optimal approach. Optimal approach would be like for this. What memory has set? If we are using has set, then this will contain only unique elements 1, 2, and 3 and 1. If 1 is again containing this is false. So in the worst case, or memory complexity order of n, and time complexity would be like order of n only. So is this most optimal approach, or can we think another optimal for this? We have an array nums 1, 2, 3, and 1. If we sort this, let's say n log n, n log n is time complexity, but we can see 1, 1, 2, and 3. So n log n complexity, and order of 1 is memory complexity. So what we can do here is, guys, like we can do, if this is same as this, then there is present duplicate. If this is not, then again we go for another one, then like this. So we are comparing nums of I with nums of nums of I minus 1 or I plus 1, like that. If this is true, then duplicate exists. If it's not, then duplicate does not exist. So yeah, this is also very pretty optimal approach. This is n log n in worst case. All right. So what we can, because I have already solved this question, so we will look into code how I have approached it, and we will try another approach also. So let's see. In this, I have nums and nums dot length integer. So I have used a in this. All right. So can we change this? So order of n and order of n. So right. So let's do uh, second optimal approach. Right. Uh, in this in nums length and array dot sort nums, then what we do for integer I is equal to 0. So do we start with 0 or not? We should start with 1 only. With 1 and node of length I plus plus. Wait a minute. Alright. Then what we will do, if nums of I is equal to nums dot I minus 1, then return true, else return false. One more thing is, if n is less than 1, turn false already. Uh, right. How do we run this code? Error here is nums dot length length is not, so what can we do here? lng th, I think we are accepting this cases. So in our first solution, our performance was how fast this is. So in runtime, we are using 28. We are beating only 28% people, and so if we are analyzing this, it would be n log n, I think, n log n, and this is memory order of n. So memory is order of n. So this is not the most optimal, because if we are using S set, then we don't need this. This is not most optimal. So if we are submitting this, what can we do? We are beating in time 47% people, and all right. So we are not able to operate. So our 1 millisecond people are there also. What is the 1 millisecond solution here? So if and if num 0, all right, and one more optimization I can think for this, because if you see some characters, all right, so try to do this also. If you are encountering any problem related to characters and strings, so we should try to apply this, if we can, this approach also. So as we all know, there are only 26 characters in a string maximum. 26 type of characters, so A, B, C, D, E, F, like this, all right. uh, right. So if we can say, if we are encountering A and S, so we can increase the value of A here. If we are encountering uh, the same value in T, then we can decrease the value of this. So plus 1 minus 1, all right, like this. So it will take us a maximum order of n time, all right, order of 1, because this is constant memory. This will take in the memory, all right. So these are character. And first, how can we do this, because we only have indexes in an array. So how can we achieve this abcd of this? Because every character has an xi value. So for a, we will equivalent this by 0 index, and this is true. We can do this also. We don't need to initialize this by this also. So we can. This also. First was 36, now 35 only. Wow. In memory, we hit 97% this time, but we were optimizing time and we optimize this. So we can beat this also, because this should be not true, because we can do this here. Character dot to lower case s. Character dot to lower case t. So s is equal to this and t is equal to this. So we don't need to do this every time here, like this and like this. Can we run this code now? Character. Why not? How to change entire string in lower case in Java. Let's do this. Alright. So this is not the method in Java. So s dot to lowercase and t here and like this. I think this is good to go now. Alright, it's accepted. Let us submit it. How many are beating now then? 35 only. Wow. 70. Alright, so we can change this. Control Z. Or now submit this. Alright, 94, 36. Alright. This is the best solution I think. For this next question we will discuss lead code 1 to some problem. To some problem. Lead code 1 number problem. Wow. This is 1 to some. What is the to some problem? Wait a minute. I think my voice uh, is voice coming good or not? जिंदे को खा देते मैं बोल रहा खा लेने नहीं और दोबारा हेलो हाँ भाई करवा रहा हूँ 10 मिनट का आध घंटा में करवा रहा हूँ all right all right guys so this is the array we are given an array of integers nums An integer target return indices of two numbers such that they add up to target. Alright. So we have to return indices of those two integers which are equal to target. Alright. You may assume that each input word have exactly one solution and you may not use same element twice, so we don't have to use same element twice. And uh, as long as we are finding one solution, we can return that only. You will return the answer in any order, alright. For example, we have this and target is 9, so 0 and 1, 7 and 9 is this. What unique solutions is there, alright. So what we can do here, guys, is so let's take that example. This example 2, 7, 11, 15, and 9. All right. So we have array nums 2, 7, 11, and 15, and we have our target which is 9. How can one approach is uh, for this we can traverse each element, and then for 7 we can 11, so like this, all right. So this will be like n plus n minus 1 plus n minus 2. In worst case it goes for n plus 1 by 2, and which is time complexity of 4 of n square, which is not optimal. So what we can do is like we have some we can update target from 9 to another thing, like target is 9, so we can minus this 2. Target is equal to 2 or 9 minus 2, and which is 7, and then the rest of the array we can use binary search to find if there is 7 or not. Right, if there exists 7 or not. Right, this is one approach. Log n for binary search, and for worst case n log n is the time complexity for us. All right. Is there another approach to do so? Except binary search, is there any another approach we can do this? Uh, we have 2, 7, 11, and 15. Target is 9. So what we can do, we can sort this out. Sort, which was like a log n. Right, then we get 2, 7, 11, and 15. What we do is we will take two counters left and right. We add this. Is this greater than sum? Yes. Then we traverse like this here, and then this. These are three approaches I can think of, and by sorting left and right pointer. So in implementation, we will implement this only, this approach. So let's go. Do this uh, dot sort nums and integer l is equal to 0, integer r is equal to nums or length minus 1, and while left is less than this is not left. If is this one index or zero index? This is zero index, all right. So if nums L plus nums R is less than target, then L plus plus else if nums L plus nums R greater than target, then R minus minus, else if nums I nums I plus nums R is equal to target, then return new int 2 L comma R, and return false. What is this asking for? Return false or true? No, 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 true false, no. Return new int like this, entity. Then we run this. Error. So should be equal to alright. So what he has done this So integer map, has map, so it has some key and value pair in the has map. And for int I is in num dot length is complement. We are calculating complement here first. Then if int complement target minus num I, all right. Every time we are calculating complement, all right. If map dot contains key complement, if complement, then return contains, then return new map contains complement, right, complement comma I, map dot get complement comma I is what, it's nums right. This is key here, this is value, and return new comma I, all right. So let's solve this by this SMAP approach. Uh, all right. Map integer z map is equal to new SMAP, right. Integer n is equal to number of length for integer I equal to 0, I is in n, I is equal to s, complement equal to target minus nums I. If map dot contains complement, return new int map dot get complement comma I, map dot open key value complement nums I comma I. Okay, this हेलो 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 हेलो